Hello friends, welcome to my channel Electricology Guru. If you like the videos, please subscribe my channel and you can put the like also. You can share the videos if you like to your friends. Actually, these videos are very useful whenever you are going to pass out from the engineering and those who are working in the industry also. Today we are going to discuss one thing that is important related to transformer. It is the open circuit test and short circuit test. Actually, we will understand here what is the outcome of this test, why this test is performed in the industry, how this is say very important related to transformer. Whenever we are calling here the open circuit test, means it is called as the one winding is kept open here, so that's why it is called as the open circuit test. What is procedure here? Say suppose I have the distribution transformer. I am going to manufacturing here the distribution transformer in the industry, and the winding is here say 400 volt is the secondary voltage, and the primary voltage it may be the 11,000 volt. So means I have the transformer of say capacity 200 kVA, then 11 kV oblique 400 volt, and this transformer is going to manufacturing in the industry. Once I make the core here, and so the winding is put on the primary side. Let us consider here the LV winding is put here on the LV side, that is 400 volt, and the other winding is the 11,000 volt. Actually, procedure is that you have to give here the rated voltage to the LV winding, and the AC winding will be kept open here. Why it is happening here? So why you are connecting the LV winding to the supply, and why the AC winding is kept open here? The answer is that whenever you are going to do the testing in the lab, whenever you are going to do the testing in the any manufacturing industry, the voltage available with your lab, so that is a low voltage, and so that's why I say the LV winding is connected to the supply side, and the AC winding is kept open here. Actually, what is exact the procedure is that you are going to apply here the rated voltage to that particular winding. Means suppose I have the winding of 400 volt, so 400 volt is the rated voltage of the LV winding, and the HV winding have the rated voltage of 11,000 volt. So what is procedure here? So you can apply here the rated voltage, that is 400 volt, to the LV winding by using any means, like I have the demostat, or say I have the auto transformer. By using that auto transformer or the demostat, I can apply here the 400 volt exactly to the winding. The outcome of the iron open circuit test is to calculate, to determine the iron losses within the transformer core. Means whenever you are going to apply here the rated voltage to the LV winding, you will measure here the iron losses within the transformer, provided so the voltage should be rated voltage. Means if the rated voltage of the LV winding is 400 volt, then by any means you should apply here the rated voltage to that particular winding. And so you can measure here the so the iron losses, whatever the loss the wattmeter is showing here, or we have the meter, that meter is showing here the every parameter, like so it is showing here the voltage, primary side voltage, or say no load voltage, no load current, no load power. So that power, no load power, it is shown here. So the total power is, or the entire power is the iron losses. Means the iron losses are proportional to voltage, and if I consider that the voltage is not going to be changed here, then so the total losses, whatever the reading shown by the meter, so these are the entirely iron losses. Now question can be here, how it is iron losses only, why you are not including here the copper losses, since in the primary, so for the LV winding also there is the winding, and this winding has its own resistance. Then so question can be arise here, so why we are not considering here the copper losses, and why we are considering here only the iron losses of this whatever the reading shown by the wattmeter, it totally say the iron losses. The reason is that the voltage you apply here, the rated voltage you apply here, But the current passing through the primary, it is very small current. If I consider here the rated current of the machine is say 100 ampere, then whatever the current we are passing for the no load test, it may not be something say 1% also. And the resistance of the winding is very small resistance there. So therefore, if I am passing here 1% of the current, then okay, so the copper losses, I square R loss compared to the iron losses will be very very small, and hence it is get neglected. So that's why whenever you are doing here the open circuit test on the transformer, okay, so you are neglecting here the copper losses. Uh, uh, on the other side, whenever we are going to conduct here the short circuit test, what is the procedure? Okay, procedure is that to the HV winding we have to give here the supply, and LV winding is connected by using any say thick conductor. Okay, so it is short circuited on the LV side, or you can connect here the ammeter. Any ammeter can be connected here. That means the capacity of LV winding. Suppose the LV winding has 100 ampere current, then okay, so in proportion to that 100 ampere, you can connect here the clamp on meter. You can make here the thick conductor across that particular winding, and the procedure that you have to apply here the voltage to the HV winding in such a way that the secondary will read here the full load rated current of the secondary. Means whenever the secondary has the rated current of 100 ampere, then okay, so we have to apply here the voltage to the primary winding in such a way that the secondary winding, or say the LV winding, will read here the full load rated current. Like 100 ampere is the rated current, then we have to apply here the very small voltage. Okay, so though the HV winding, suppose in the previous case we have taken here the 400 volt is the LV side voltage, 11,000 volt is the HV side voltage, then okay, so though we are connecting here the HV winding to the supply side, we should not apply here the rated voltage. Okay, so rather than that, we should apply here the voltage in such a way that okay, so the rated current will pass through the say the LV winding, and whenever the rated current is passing through the LV winding, then okay, so the current will be here, the rated current is there, the secondary has its own resistance.